Uh, so, a very good afternoon to all of you. My name is Nitin Tomar, and I am a Prime Minister Research Fellow in the Department of Mathematics at IIT Bombay. Today, in this session, we'll be discussing some problems related to Cauchy integral formula, Liouville's theorem, etc. So, let's start. So, is my screen visible to all of you? Am I
Yes,
audible
sir.
to all of you?
Sir,
Yes,
it's
sir.
visible.
Okay. So again, let's start. So question one. So again, in the beginning, I want to say this is more like a discussion forum. So we all are here to learn. So your contribution will make this class interesting. Okay. So it is given that f, this function f, is holomorphic in omega. So omega is some domain in C. Uh, okay, let me write. For a domain, for a domain omega in C, the function f is given to be holomorphic. F is given to be holomorphic, and gamma denotes the unit circle. Gamma denotes the unit circle centered at 0, centered at 0. And one more thing, the disk, the closed unit disk, the closed unit disk d bar will denote it by d bar z in C, such that mod z is less than equal to 1. This is contained in omega. Okay. So there are some parts in this question, and we will see one by one, or rather we'll give it in a one hit. Okay. So if f is a holomorphic function, what can you say about, so it will have a power series representation, right? Yes or no?
Yes,
Yes,
sir.
sir. Yes. So f admits a Taylor series representation. Taylor series Taylor series representation, and what it will be f of z 1 upon 2 pi iota, sorry, what will be the Taylor series representation? So it will be of some this form, right? A n z n going from 0 to infinity for all z in d bar, for all z in d. Is this true? where where you can write this, you can also determine this coefficient, right? Where a n is, क्या होगा a n? Anyone?
1 by
1 by
2 pi
2 pi
I
I
Mm-hmm.
into
into
nth
nth
derivative
derivative
of
of
nth
Yes.
nth
derivative of
derivative
z
of z
naught
No,
naught
directly if you write it as, it will be nth derivative of f 0 by n factorial, right?
and 0 by
0
n
by n
factorial.
factorial.
Yes, yes.
Yes. For all n in 0, 1, and you can also determine it, right? It has one more representation. If you know, it will be equal to 1 upon 2 pi iota gamma fz upon zn plus 1 dz. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. So this being clear, so or equivalently, because in the question, equivalently, what we can say, equivalently, fz is a naught plus a1z plus a2z square for all z in D, where this an where this an minus 1 is actually 1 upon 2 pi iota fz by zn tz and gamma, and this is for all n starting from 1 to this. Same thing, right? This is the same thing. Do all of you agree with this?
Yes, sir.
Yes, sir.
Agree,
Agree,
sir.
sir.
Okay. Now let's see what happens, because in the question we have to consider some cases for each question. So let's say case 1. So in the option 1, it has been given that this integral for f is 0 for every even number. So for every even number n in n. Okay. So then does this mean, so then what is the relation between f of minus z and f of z? Okay, we have to figure this out. What is the relation between these two? Okay, should I write like bigger? Is it visible to all of you?
Yes, sir.
Sir,
Visible,
visible,
sir.
sir. Yes, sir.
Okay, so should I write bigger, Darshana?
Yes,
Yes,
sir.
sir.
Oh yes, fine. Is this fine now?
Yes.
Yes.
Yeah, okay. So let's see. So the problem with this way of writing is that I cannot see much of, because then it becomes just a minute. Okay, this is fine, right? Now, if for every natural, so remember this fz was, so this condition is same as saying, an is 0 for every even number, right? An minus 1, sorry. Yes or no? So you
Sir, A
A
and
N
compare,
minus, sir.
minus, sir.
with this. We have, so this is the thing that I'm using. Huh? So a subscript n minus 1 is 0 for every even number. So what does this mean? That, so you put n equal to 2. The even number starts from 2. So what does it become? What does it become? So this implies, even minus 1 becomes odd, right? So a1, a3, a5, all these are 0, right? Yes or no?
Yes,
Yes,
sir.
sir.
Darshana?
Yes,
Yes,
sir.
sir.
Yeah. So what form does fz takes? Fz takes a naught plus a2z square and so on, right? Or let me write one more term, a4z4 and so on. So this is a property of even function, right? So this is an even function. Even function means if you replace the argument z by minus z, the answer will be same. That is f of minus z. It is same as f of z, right? Because you have only square, like even powers, z square, z4. Is this clear?
Yes,
Yes,
sir.
sir.
So sorry, f of. So in this case, this will be equal, right?
Yes.
Yes.
Okay. Now what happens? So the case 2 will be when the same thing is 0 for every odd natural number. For every odd natural number. For every odd. Why I'm writing natural? So what should happen? Can anyone tell?
Even
Even
term
term
0
zero,
in a
we na
A2,
A2,
A4,
A4,
A6.
A6.
Exactly, because it is 0 for every odd. Because see, the this thing implies that again we will use the same logic. A n minus 1 is 0. Now for every n, a subscript n minus 1 is 0, and a odd number minus 1 is an even number. So this implies a2, a4, all of even a naught, right? We should start from a naught, a2, a4. All of this will go to 0. So then how does fz look? So fz becomes a1z plus a3 z cube, a5 z5, and so on so forth, right? So what is this property? This is an odd function, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
F
f
of
of
minus z
minus
is
z is
equal to
equal
f
to
of
f of
minus f
minus
of
f
z.
of z. Exactly. Okay. So this is there. Now case 3. Case 3 is if all of them are 0. Case 3 is f of z by zn dz is 0. Uh, so you know this symbol?
Yes,
Yes,
for
for
all.
all.
Okay, thank you. So for all n in n. So then what should happen? Then this implies that a naught, a1, all of them are 0, right? Yes or no?
Yes.
Yes,
Yes.
yes.
So what does f become? So this is for all z in d. For all z in d. This is in z in d. So this implies fz is
0.
Zero.
0 in d, right? In fact, in omega also by identity theorem, right?
Yes.
Yes.
So by identity theorem. So what does identity theorem says? That if a zero set has a limit point inside the domain, then the function has to be 0, right? So remember, our omega was something like this. Just a minute. I'll use some. Yeah. This was our omega. Some domain. I don't know, like some domain. Okay. And there you had the disk. So this was our domain. So can anyone, so we know what does identity theorem says, right? Identity theorem says if a function is holomorphic in a domain omega and the zero set of f has a limit point in omega, then the function is going to be zero in omega. Okay, I hope this all of you must have read by now. So this was our gamma and this was center zero. Now what we have proved that inside this D, inside this open unit disk, f is zero, right? We have proved this. So by identity theorem, what is the zero set? Zero set is at least, zero set at least contains this open unit disk. So and open unit disk has a limit point in D itself, therefore in omega. So hence by identity theorem, f is going to be zero. So is this clear?
Yes.
Yes. Okay.
Yes, sir. Okay, sir.
Yeah. So let me add sheet. Huh? How do I do that? Okay. Okay. So let's start with another question. So today's question are mostly based on Cauchy integral formula, Liouville's theorem, or identity theorem. All the big theorems. Okay. So you know what is an entire function, right? What is an entire function?
A
A
function is
function is
differentiable
differentiable
in
in
C.
C. Exactly. If a function which is defined on complex entire complex plane and which is holomorphic, that is to say it is differentiable at every point of C, then we say that that function is holomorph entire. Okay. So this f is holomorphic. So we say that f is entire. Okay. So let me write just entire, and let it has the representation some real part and u plus iota v, right? Real part and imaginary part. U is called the real part of f and v is called the imaginary part of f. Now you have to tell me these, huh? So how should I do? Okay. So it has been given that f is bounded on every vertical strip, on every vertical strip. So how does a vertical strip look like? When we say vertical strip, what does come what is the thing that comes in your mind? Something of this sort, like you fix some a and you fix some b, right? Okay. Yeah. So this is my a and that is my b. So in between in between means in this domain here. So how does it look like? All those z in c whose real part lie between a and b, right? This will give you the vertical strip, because x axis, what is the
Yes.
yes. Yeah, okay, fine. For every real number a and b, so this is on every vertical strip, that has to be taken care of. Okay. for every vertical strip and for every AB in R. Obviously, A less than B in R. Then what can you say about F? Then can we say that F is constant? Then can we say that F is constant? See, one thing that you should know when we are doing complex analysis, whenever there is a condition on, so if you're starting with, okay, if you're starting with some holomorphic function f on omega, okay, this is one kind of a trick that I would tell you, and it is holomorphic. And if some information is given about real part, then you consider the function e power f always. So what I want to say, if you have a holomorphic function and you have some information about the real part of f, okay, then you transfer, then you, it will be easier for you to consider g as e power f. You know why? Because mod g, what it will be, it will be e mod ef, which is mod e u plus iota v, which means real part of f is u already. And what is mod of this? What is mod of this? It is mod eu times e
E to
iota v,
E to the power u.
e to the power u, which means e to the power real of f. So see, when you consider this function e power f, so the real part of f appears here as in the modulus of g, okay. And similarly, if some information is given about the imaginary part, then you consider this function h is equal to e power iota f. And with this logic, you will see that this e power f, it will e power iota f, sorry, mod h, it will become minus v plus, sorry, yeah, minus v plus iota u. So its mod will be e minus v. So if you consider e minus iota f, then it will be this and this. So plus will appear here. So this imaginary part will appear in the modulus of h. Okay. And these questions you will find, because these are very standard questions when you're learning Liouville's theorem. Okay. So I'm going to raise that. I hope the idea is clear. So again, some information about the real part is given, right? Yes or no?
Yes.
Yes. So what should we do? So like again, so what if we want to conclude that it is a constant function, then we know that Liouville's theorem is one thing, right? If we So we have been given an entire function. What does Liouville's theorem say? It says that any entire function which is bounded, it has to be constant, right?
yes, sir.
Yes or no?
Yes, sir. Every
Every
bounded
bounded
entire
entire
function is
function is
constant.
constant. Yes, that's what I said. Every entire function which is bounded has to be constant. So, so if our fz is uh, mm, so how do we do it? Just a minute. So how will you proceed? Okay. So let's see what happens. Okay. I think this won't be true, because see, if you take this function e power z, okay, then what does it become? It becomes ex e iota y. Yes or no? If you are assuming z is equal to x plus iota y, this f is an entire function, right? So this is an entire function, and what is the value? And moreover, mod of fz, we have discussed this, it is e power x, and this function we know e power x, it will be bounded on each vertical strip, right? So mod f is bounded on each vertical strip, but this is not constant, so this option is false, this option is not true, so this is false. Do you get it? Is there any doubt? Hello.
Yes, sir.
What doubt you have?
Sir, this is not constant.
Yeah, yeah, okay, yeah, it is not going to be constant. And same thing we can say for the horizontal strip also, right? I mean,
That's also not constant.
exactly.
E power
So,
y.
so what I want to say, if the same question, if there is the same question about the vertical strip, so how does a horizontal strip will look like? On every horizontal strip, here here you'll have imaginary part, right? Then still this f will not be constant, right? Yes or no?
Yes.
Yes. So like you will have a domain like this, vertical strip. So if this is your axis, if this is, so it will be something like this. Yeah. And what function will you consider for the counter example? You just consider fz equal to e iota z, right? Then you will see that this option will no longer be true. Now the question that I want to discuss, if real part of f is bounded, then what can you say? If real part of f is bounded, then what can you say about f? Then is f constant? So again, you consider this function e power f, what will its mod be, modulus be? Its modulus will be e real part of f, yes or no?
Yes.
Yes. So
Yes,
if
sir.
real part of f is bounded, what does it mean? That it will be, so let me use z also. This is real part of f of z, so it will be less than some e power m, right? For all z in whatever, for all z in c. Yes, because real part of f is bounded by m, we have chosen that m, and exponential is an increasing function. Okay, so we have, so what does it imply? E power f is a bounded entire function, is a bounded entire function. Yes or no?
Yes.
Yes. So can I say e power f is constant? It is
Yes,
some
sir. By
constant.
Leo's theorem.
Exactly. Exactly. So then f will be constant also, right? And how do we prove it? You just take derivative both side. So what will be the derivative? It will be f prime z e f z equal to 0. Yes or no? Yes or no?
Yes,
Yes,
sir.
sir.
Because you cannot take logarithm directly. In complex analysis, logarithm is a very dangerous function. Now this exponential is never 0. So what does it imply? F prime z is 0. As e power w is never 0. So is this fine up until now? Now derivative of an entire function is 0. What does it mean? That f has to be
Constant.
Constant.
constant. Okay. So if if you
Sir,
have
I
any
have
Sir, I have
one
ha-
one
doubt,
doubt,
sir.
sir.
yeah, yeah.
If
If
U
U
is
is
bounded,
bounded,
then
then
we
we
can
can
say
say
V is
V is
bounded or
bounded or
not.
not.
Yes, yes. If u is bounded, then you know that f is constant, right? Then we will always be bounded.
Okay, sir.
Okay, sir.
Okay.
Okay, sir.
Okay, sir.
Thank you,
Thank
sir.
you, sir.
Yeah. So the question is now the next question is what about the same for imaginary part? If imaginary part of f is bounded, then f is also constant, right?
Yes, sir.
Yes, sir.
By
By
previous
previous
result.
result.
By previous discussion, you just consider e power iota f z. We know its modulus will be actually minus iota f of z. So it will be e power imaginary part of f of z, and using the same, like, so this is done, right? Hello. So then this will be some e power n for all z in C, where n is such that where n is such that imaginary part of f is less than equal to n. Then we are done, right? Because are we done here? I mean, we can use the similar argument for the above part, same as the above part.
Yes,
Yes,
sir.
sir.
Okay, thank you. And all this is happening because of which theorem? Lewis theorem. Okay, all of this is happening. So you just complete the arguments. Now the next part is again f is an entire function, and suppose for every compact set, for every compact set, no, sorry. Suppose that there is a constant m such that for every compact set k. So then f is constant. What do you think? What should be the answer? Hmm? So for every compact set k, they you have a constant. Okay. So it might so happen that this constant will change with the compact set. Okay. Hello.
Yes,
Yes,
sir.
sir.
So this constant may change with the compact set. So what do we have to prove? That this f is constant. Okay. So the main idea that we'll be using is that derivative at any point is going to be zero. So choose, take any arbitrary point, take any arbitrary point. Okay, let's say zeta in C. Okay. Now you consider this disk centered at Z and zeta, and let's say radius some r, or let's say use capital R. Okay. So this is a compact set, right? This is a compact set, closed and
Yes,
bounded
sir.
set.
Yes, sir. Close it bounded.
Yes. Which theorem is this? Now, what can you say about f prime xi? F prime zeta, what can you say? By Cauchy integral formula, it will be 1 upon 2 pi iota. Okay. This fz, z minus zeta, dz, and this is mod z minus this over this curve. Okay. Because we have an entire function. Okay. So you don't need to worry. This is Cauchy integral formula. Yes or no?
Yes,
Yes,
sir.
sir.
Cauchy integral formula. So now you have this ML inequality. You must have heard of this. So can I say that this will be 1 upon 2 pi r, 2 pi, and do not fix this r. Okay. Okay, let's take yeah, we can, yeah. So this r, okay, let's take this curve only. So it will be less than equal to mod fz, then okay, let us do step by step, otherwise it will be a mix, upon mod z minus this. Is this clear or not? This step is clear?
Yes,
Yes,
sir.
sir.
Okay. So now we know that this, for this compact set, we have a constant m, right? So it will be m by 2 pi, then uh, so it will be some 2 pi, I think it should be r. So it will be m by r, right? You have heard this ML inequality, right? So this ML inequality, you please refer to that. Oh, this should be square, right? This should be square. Yes. Then it's fine. Yeah. Quotient, hey, you please observe carefully, okay? The derivative for it, for the derivative, it should be square in the quotient integral formula, okay? So this r was arbitrarily chosen. This r was arbitrarily chosen. So you can choose r goes to infinity. So then this will be greater less than equal to 0. So this tends to 0 as r tends to infinity. So this is going to be 0, and because zeta was arbitrary, so this holds for all c, so hence f is constant. Is this clear? So one thing, that this bound is uniform bound. Okay, it is not changing with compact set. Then it becomes Liouville's theorem only. I mean, yeah.
Sir,
Sir,
why
why
here we
here
are
we are
not
not
using
using
Lewis
Lewis
theorem?
theorem?
No, it's a proof of Lewis theorem. Okay.
Yeah,
Yeah.
yes,
Yes,
sir.
sir.
See, because this M, it has to be uniform, right? If M changes with, if, because we'll, what we'll do, we'll change, we'll keep on increasing R, right?
Oh,
Oh,
yes,
yes.
So if this M is not uniform, in the sense if it changes with R, so then numerator will also change here, right? Then we cannot say it goes to 0. Yes or no?
yes,
Yes,
sir.
sir.
Yeah. So that
Okay,
Okay,
way,
M
M
fixed.
fixed.
huh?
M
M
fixed,
fixed,
sir.
sir.
Yes, yes.
Yes.
So now this is called periodicity. These are all good questions and standard questions. Okay, if you're learning complex analysis, then all of these are standard questions. So again, f is an entire function. Okay, throughout the series, throughout this question, f is an entire function. So it says, then f is constant. So what we have been given is the following. So one is here and iota is here, right? So so in this square, like in this square, okay. So after every, like what does fz plus 1 mean? That you cross, so f, so it says f of z plus 2 is same as f of z, right? Yes or no?
Yes, sir.
Yes,
So
sir.
Yes,
Yes,
sir.
sir.
Because
yeah,
F is
F is
constant.
constant.
yeah. So like it will say that outside this, no, what I want to say that first of all, first thing that you should observe is this f of z plus m is same as f of z for all m in integers, right? And this f of z plus iota n, this is also same as fz for all n in integer. Do you all agree with this?
Yes. Yes.
Okay, it's good that you all agree with this. Okay, so can I say, now I'm writing one thing. Can I say, so if like, so what should we denote with this square? So let's say omega. If omega is my square, if omega is the square, which square? This z, such that this real part of z, it's in between 0 and 1, and imaginary part of z is also between 0 and 1. This is the square, right? So then can I say that f of c is same as f of omega? Because see, you choose any point here, then it is just, like you keep on decreasing using this relation and you land inside the square. Yes or no?
Yes. Yes.
Is this so? For example, if you are here, then you keep on decreasing one, or like 1 plus iota, and you will come back to the square. So what I want to say, that the range of f of c, it is same as range of f over this omega, and this omega, remember, is compact set. So can I say that mod of fz, so this f, since omega is compact, so this is, you check, if omega is since omega is compact and f is continuous on omega, because it is entire, so therefore it is continuous. So it
When F is
implies,
bounded.
yes, it is bounded for all z in omega, right? But
Yes,
then,
sir.
yes, sir, it but because f of omega is same as f of c, so this fact gives us f of z is less than m for all z in c, right? So then Liouville's theorem, so this implies f is constant. So we are done here, right, with this part?
Yes,
Yes,
sir.
sir. Yes, yes, yes.
Yes,
Yes,
sir.
sir. No, Thangeshwaran, do you have some doubt?
Sir,
Sir,
every
every
periodic
periodic
function is
function is
analytic or
analytic or
not,
not,
sir?
sir? Which functions?
Every
Every
periodic
periodic
composite
composite
functions.
functions. You can define periodic function anyway, right? I mean, they need not be holomorphic.
Okay,
Okay,
sir.
sir. Okay.
Okay,
Okay,
sir.
sir. Okay, sir. Periodicity is a very, I mean, these two are
Every
unrelated.
analytic function,
Neither
every
of
analytic
them
function is
implies
specific or not,
another.
sir?
Huh?
Every
Every
analytic
analytic
function is
function is
periodic.
periodic. No, definitely not. Uh, for example, this z, fz equal to z. It's not periodic, right?
Ah,
Ah,
yes, sir.
yes, sir.
Okay.
That is why I said none of periodicity and analyticity. These are two non-related property. None of them imply the other.
Okay,
Okay,
sir.
sir. Okay. For example,
Uh,
continuity and analyticity is related in the sense an analytic function is going to be continuous in the domain.
okay,
Okay,
sir.
sir.
Okay,
Okay,
sir.
sir. Yeah.
Okay,
Okay,
sir.
sir.
Understood.
So all these questions from in this part is going to be related to identity theorem. Identity theorem. So I hope we know, all of us know identity theorem. So do you want me to repeat? Okay, so what does identity theorem says? Okay, let us just see for a brief. Oh, okay. If f is a holomorphic function in omega, if f is a holomorphic, if f from omega to c is holomorphic, and remember omega is a domain, okay? This we are taking to be domain in C, such that z of f, z of f means zero set of f, that is the point in omega where f of z is 0, has a limit point in omega. If it has a limit point in omega, if it has a limit point in omega, then f is 0. So this is the identity theorem. All of it is, I know this as it is, this version. There are many versions of identity theorem. So one direct thing that you see, if you know this is your omega and f is, let's say, 0 on this line, then what can we say about f? This is the, like, 0 set of f contains this line, then what can we say about f? So this line, this is a closed set, right? Hello, am I audible?
Yes, sir.
So if a function, if a holomorphic function has zeros on this line, then what can you say? So this line segment, This is closed, right? Because it is a
Yes.
compact set, and every closed set has all its limit point.
Yes,
Yes,
sir.
sir.
So by identity theorem, it will be zero. This function. Okay,
Yes,
if
sir.
if you are not comfortable in this language of limit point, okay, then I should write it as one another version. If like, okay, so this is first version. Okay, now I'm writing one different version that you might be comfortable with. If so, let's say Zn belongs to Zf. Okay, there exists a sequence of, so you know this symbol, right? Or should I write? Okay. Oh God. Yeah. So there is a sequence. There is a sequence. There is a sequence Zn in the zero set of f. Zf we have defined above, which means f of Zn is zero for such that this Zn converges to Z, and this Z belongs to omega. It need not belong to zero set of f. Okay, then f is zero. So is this version more clear?
Yes,
Yes,
sir.
sir. So now can you answer this line question? So if this zero set of f is a line, then you know so this is my z, and you can always choose one zn approaching to this point, right?
Yes,
Yes,
sir.
sir. So this z, again I am repeating, this z need not be in zf. Okay. Okay.
Yes,
Yes,
sir.
sir. Okay, now let's do the question clearly. So quickly we'll go through. I'll take 15 more minutes. Okay. Sorry, guys. So does this identity hold for all z in C? Does this identity hold?
Yes,
Yes,
sir.
sir. We know in real it holds, right?
Yes.
Yes. So for, let's say z in real, let's say for x in real, sine square x plus cos square x is 1. Okay. Now you define, so I'm giving just one idea how to write. So this is the question. This, okay, let me underline it. So this is the question. So you define f of z as sine square z minus cos square z minus 1. So this is an entire function, right? Sine is entire, cos is entire, everything is entire here, right? It's a combination of entire function.
Entire
Entire
functions.
functions. Yes. So fz is an entire function, f is an entire function or not? Just give me a yes or no. Hello?
Sir,
Sir,
science
science
will
will
get
Yes,
get
sir.
absolutely.
Absolutely.
Sine z is entire. This you agree?
Yes,
Yes,
cos Z
cos z
is
is
entire.
entire.
Yes, sir.
Product
Science that
of
is
co-entire
entire
function is
function.
entire, right?
Yes,
Yes,
sir.
sir.
It
It
should be an
should be an
entire
entire
function, no?
function, no? Yes,
Science
yes,
equals.
it is. Darshana, what is your doubt?
Sir, I
Sir, I
think
think
FZ is
FZ is
sine
sine
square Z
square z
plus
plus
cos
cos
square
square
Z.
z. Oh, okay. It should be plus cos. Otherwise, we will not get this inequality, right? Yeah. Yeah. This function we have to work with. Sorry. That was also entire function, but that won't give us the required equality. Thank you, Darshana. Yes. So this is one entire function such that f of real line, f on real line is 0, right? Yes or no?
Yes,
Yes,
sir.
sir. So by, can I say by identity theorem f is 0? See, on a line it is 0, right? All of you, can I say this? Fz is 0 for all z in C. Now what does it imply? That sine square z plus cos square z equal to 1 for all z in C. Is this clear?
Yes,
Yes,
sir.
sir.
Okay. So
Yes,
second
yes.
question. Okay. So let me use this now. F and G are holomorphic in the punctured disk. D we have defined above. Open unit disk centered at 0. Okay. So it's like you have you have one open unit disk and you remove the 0 part. So it is a domain, right? It is still an open set such that this f of 1 by n is actually g of 1 by n for all natural numbers. Okay. Then does this hold that fz is equal to gz for all z in d minus 0? Did you understand the question? Okay, let us first do this way. Otherwise, it will be confusing. Okay, let's first have this. Okay, so you know open unit disk, right? Should I draw it? Hello? See, if you don't say yes or no, then I don't know whether you're understanding or not. If-
Yes,
Yes,
sir.
sir.
Okay, so D is a domain, first of all. D is a domain, and you define hz to be f of z minus g of z. What can you say about this function? Can I say that this is holomorphic in D?
Yes.
Yes.
Because it is a difference of two holomorphic function, right?
Function.
And what can you say about h of 1 by n? It is f of 1 by n minus g of 1 by n and
Zero.
0 for all n in n. Okay, so this if I define zn to be 1 by n, right? So this sequence is in 0 set of h, yes or no?
Yes,
Yes,
sir.
sir.
0 set of f किससे डिनोट किया था हमने? Z of h. And where is this sequence converges to? 0.
Yes,
Yes,
sir.
sir.
And no, such that no such that no, we have Zn converges to 0 and this 0 belongs to D. So we have this second characterization, this one, right? So if sequence of 0 set of a function has a limit point, I said like it need not be in ZF, right? So here in this question 0, it's in the domain, that is more than sufficient. Okay, so what can I say by identity theorem quickly? Can I say that h is 0?
Yes,
Yes,
sir.
sir.
Yes.
It is
It
it is
is
zero.
zero.
So what does it mean h is 0? It means f is equal to g on